Hey everybody, Mr. Covey here, and this is the first of 4 planned review videos. And the purpose of these videos is not to be comprehensive. We're not going to review everything on the AP test in 4 videos. If I wanted to make a video that reviewed everything for the AP test, it'd be a year and a half long. Because you've been learning calculus for a year and a half. So all I'm trying to do here is review some stuff. Everything I review in this video, you better know how to do. Okay, because these are the kind of things that if they show up in the AP test or when they show up in the AP test, we, being me and Mrs. Lemke, would expect you to nail these topics. Okay, because we're going to review them. You guys are going to do awesome. Okay, so this first one's going to touch on a couple of MAH stuff, topics, talk a little about parametrics, talk a little about L'Hopital's. Okay, if you are unfamiliar with something I'm talking about or not following what I am saying, go back and review it. You're not supposed to just watch this video and be able to remember how to do these things if you don't. This is supposed to help inform you as you prepare about what you need to go back and review more. And going back and reviewing means looking back at old videos, looking back at your notes, that kind of stuff. Looking back at old tests and quizzes. Cool. All right, I'm going to get to it now. First question, we're going to do a few limits here. Okay, you approach this limit. As with every limit, you try and do direct substitution. Oh, by the way, I did all the problems in advance, so I'm just going to talk through them. You try and do direct substitution. You with me right here? Yeah. You get 0 over 0. That's good. That's good because we're set up to do L'Hopital's. Please remember that on the AP test, on a free response question, you need to write out 3 things. You need to write out that the limit as x goes to 0 of the numerator equals 0. The limit as x goes to 0 of the denominator equals 0. 0 over 0 is an indeterminate form, therefore L'Hopital's rule applies. This doesn't need to be written on a multiple choice question, obviously, because you just got to pick the right answer. But this is all set up. How do you do L'Hopital's? Derivative of the top divided by derivative of the bottom. Derivative of tan of pi x is secant squared of pi x times pi because of the chain rule. Now we are able to do direct substitution and we get out an answer of pi. Okay? This is a standard, straightforward L'Hopital's rule question. Next one. Similar. You approach the limit, you do direct substitution like you do with every limit, you get 0 over 0. I should write all this stuff, but I didn't again. But in general, for a free response, you should. I do L'Hopital's. Okay, you need to know your trig derivatives, derivative secant, secant tan, derivative cosines, negative signs, so it ends up being positive. I get 0 over 0 again. Remember, L'Hopital's can be applied as many times as you need it. If you get an indeterminate form, which remember is 0 over 0 or infinity over infinity. Those are the 2 indeterminate forms that allow you to use L'Hopital's. If you get it again, do L'Hopital's again. Please be careful about this derivative. I did product rule here. And first times derivative of the second plus second times derivative of the first. End up getting secant cubed plus secant tan squared plus cosine. I got 2 in the denominator. I did direct substitution. And I got 1. Cool. Third one here, we focus a lot on this. This is when you do direct substitution and you get one of the indeterminate forms that's not 0 over 0 or infinity over infinity. So if you want to look at those, look back at your notes, but 0 to the infinity is an example of one of those indeterminate forms because it's like, I don't know, is it 0 or is it infinity? I don't know. It's kind of confusing. Okay. Or sorry. I don't know why I said 0 to infinity. It should be infinity to scratch that. It should be infinity to 0. Come on, Mr. Covey. Remember, this isn't really what we're going to write down necessarily later, but this is what we're thinking. Oh, if you do direct substitution, it approaches infinity to the 0 power. This is indeterminate. Okay, and this is one of the indeterminate forms. That isn't set up to do L'Hopital's right away. We have to do some work. Okay, we have to do some rewriting. And remember the ones that have exponents that are indeterminate forms? The work you have to do involves natural logs. Specifically, what you do is you set y equal to whatever limit you're trying to do. You do the natural log of both sides. And that allows you to bring the exponent down out front. Okay. Why is that good? Because then you can rewrite this product as division, and now you have a limit which when you do direct substitution, it's infinity over infinity in this case, or it could be 0 over 0. Either way, it's set up for you to do L'Hopital's. Okay, so if you get an indeterminate form that has an exponent, that's when you're going to have to do this natural log of both sides. What do you do then? You do L'Hopital's. Derivative of the top, derivative of the bottom. Do direct substitution, you get 0. Please remember that 0 is not bad. 0 is just the answer. Like if you do direct substitution and you get 0, then your answer is 0. Don't forget, because we natural logged at the beginning, we have to undo that natural logging by exponentiating at the end. So our answer is not 0, it's the ln of y equals 0. So y is 1. I think you guys will remember this L'Hopital stuff. Hasn't been too long. Moving on. Good old-fashioned related rates. Okay, so let's read this real quick. The airplane is flying horizontally at an altitude of 3,000 meters and a speed of 480 kilometers per hour. It passes above, or passes over an observer. How fast is the distance from the observer to the airplane increasing 30 seconds later? Okay. Couple things here. I hope this jumps out to you as a related rates problem. Why? Well, they're talking about, first of all, something that has some type of geometric situation going on here with a lot of related rates do. It's talking about rates of change with respect to time. Related rates questions are always with respect to time. And it's asking you for a certain rate. Okay, if they're giving you a rate, asking you for another rate, all these rates are related. It's related rates. Okay. What do you do for related rates? You draw a picture. This is the picture you should draw. Please pay very close attention to this part. First, we had all this messed up unit stuff. So I'm going to change that 3,000 meters to 3 kilometers. Okay. Second, notice in this picture, here's the air. I forgot to draw the airplane. I'm going to pause, spend about 45 minutes drawing an airplane. All right, it's about a half hour later. There's my airplane. Notice that when I drew this picture, the only number I put in was 3. And the reason I put in that as a number is that is not changing. So in this situation, the airplane's coming in, whoosh, and X is changing, how far past the person it is. Y is changing, how far it is away from me. What's not changing is its altitude. And so that's why I put in a number there. The other things stay variables. Okay? Okay. Next, just a side. Again, we had a units issue here. This was in hours. They give this to me in seconds. I'm just going to make 30 seconds into 1/120th hours. Once you have your picture, you talk about how the different quantities, the different variables in the picture are related. This is an easy related rates one. What's the formula relating these numbers? Pythagorean theorem. 3 squared plus x squared equals y squared. I do not sub in anything for the variables yet. I'll repeat that again. This is changing and this is changing. So I don't sub anything in for them yet. I do the derivative first. And what do I do the derivative? With respect to time. With respect to time, with respect to time. That's what related rates are. Related rates are you set up an equation, you differentiate it with respect to time. Yeah. So here's my derivative. 2x. Oh, I differentiate it with respect to time. I have to do that implicit differentiation idea. I have to add dx dt. What's the derivative of y squared? 2y. dy dt. This is the equation that is relating the two rates, and this is what I'm going to work with. This is what I'm going to sub into. Okay? Please pay attention here. X is the distance the plane is past me. Dx dt is the rate of change of that distance. Y is how far the plane is from me directly. The distance from me to the plane. Dy dt is how that distance is changing. It is asking me how fast is the distance from me to the airplane increasing. It's asking me for dy dt. Related rates questions always ask you for a derivative, a rate. Okay? So I'm just going to sub in what I know. Well, what's x? Well, I don't know x. Oh, wait. Once I do the derivative, I'm allowed to take into account that I'm just looking at this picture at a single second. So I am going to just pause this picture 30 seconds after the plane flew over me. At that point in time, I do know what x is. Well, if 1/120th of an hour passed and I'm going 480 kilometers per hour, x is 4. And if x is 4, I could do Pythagorean theorem and say y is 5 at this point in time. So when we do our subbing in, we're just considering a single point in time. Okay? They tell me how fast x is changing. That's dx dt, how fast the plane is flying. So I know dx dt, I know x, I know y. I'm going to sub those three things in and solve for the fourth thing, which is dy dt, which is what I was trying to find. Okay, and that's kind of always how related rates problems go down. You have a relationship. You keep variables, things that are changing. You differentiate with respect to time. You allow yourself to consider a single point in time. You figure out all the variables you can at that single point in time, and you solve for the rate that it's asking you. Yeah. They're really not as bad as you might remember. Cool. Cool. Moving on. Let's dive into some, parametric stuff. Okay. This is a calculator question, so we're going to use our calculator as much as we can. They give us a velocity vector. Please don't get scared of this word vector. Okay. They give us a x velocity and a y velocity, and they tell us certain times to use. This is totally parametric because we have an x and a y depending on time. Okay. They also give us this initial condition that at time 0, the position is 3, -4. Okay. First question here, find all values of t at which the tangent to the path is vertical. Okay. Vertical tangent. Vertical tangent lines when dy dx is undefined. When is dy dx undefined? Well, in parametric world, you should have in your head this. Dy dx equals dy dt over dx dt. Check, 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 check. Cool. So when is this going to be undefined? When the denominator is 0, when dx dt equals 0. Okay, simple enough. I'm going to figure out where dx dt equals 0. How am I going to do that? I'm going to set dx dt equal to 0. I know what you're thinking. Wait, you forgot to do the derivative. I don't forget things. Nice try. No, I'm just kidding. They gave us dx dt, so please be careful about this. If they gave me x and y, then I'd have to do dx dt to figure out what dx dt was. They just gave me dx dt. So I'm just trying to figure out when this equals 0. I'm going to solve that on my calculator. Please make sure that you can solve equations on your calculator. You put this in for y1. You put, well, in this case, you're going to have to put this in for y2, but you can if you want. You figure out where they intersect, or you find the zeros of that function. Please pay very close attention to whatever domain we're talking about. These are the two times where dx dt equals 0. It is also worth checking to make sure that this doesn't also make dy dt 0, and they don't, so we're good. Second question here. Find the acceleration vector at time 2. I have the velocity. I got a vector because I have two components. How do I find acceleration? If I have velocity, I do the derivative of both of those, and I plug into it. Okay, check. I did that completely on my calculator. If you are rusty on the calculator stuff, please review it. There's a calculator sheet on Schoology. You should know how to use this n deriv thing. Type in your function, whatever. Let's say I want to find the derivative of x squared. I'm differentiating with respect to x. I wanted to find it at x equals 8. Let's say the derivative of x squared at an x value of 8 is 60. So you should remember how to do that. Although we are doing a parametric equation, you do not have to be in parametric mode to do these derivatives. And in fact, you shouldn't be. Next question here is a little trickier. Oh, no, never mind. It's a later question. We're fine. Speed. It's a formula. Square root of dx dt squared plus dy dt squared. Check. Speed at particle at time 2. Plug it in. Check. Make sure you can type that in your calculator right. I got 1.525. Cool. Okay. Moving on. This is a throwback particle motion MAH stuff. A particle, usually they have it moving along the x-axis. In this case, it's along the y-axis. We've got a particle moving up and down. They give us the position function. They're going to ask us a bunch of stuff about velocity and acceleration, okay? If I have position, how do I find acceleration? Well, acceleration is the second derivative of position. So I'm going to take my position. This is a non-calculator question. I'm going to do the derivative. Don't forget chain rule. This y prime is my velocity vector. Sorry, velocity function. In order to get the acceleration, I need to do the derivative of that. Again, don't forget the chain rule. It's asking me the acceleration at time 3. I'm going to throw in 3. I'm going to get cosine of 4 pi. 4 pi's coterminal was 0. Cosine of 0 is 1. So my answer is just negative 16 pi squared over 9. Okay. Question B. Determine if the velocity is decreasing at time 3. Be careful here. Not if the velocity is negative at time 3, if the velocity is decreasing. In other words, if the derivative of velocity is negative at time 3. Velocity decreasing means derivative of velocity is negative. What's the derivative of velocity? Well, the derivative of velocity is acceleration. So they're basically saying, is the acceleration at time 3 negative? Well, I just figured out that it was. So y prime is velocity, and since the second derivative, or the derivative of velocity, or the second derivative of position, at time 3 is less than 0, I know that y prime, my velocity, is decreasing at time 3. Okay. Please be careful about making sure you're not thinking about velocities being negative, but thinking about when it's decreasing. I'm going to pause it here for a second. Again, I cannot emphasize enough. If any of this is like, you're like, oh, I totally forgot that. Cool, that's fine. Go back and review this. This is supposed to help you judge what you do and don't remember. Cool. And then do the review that you're going to do as much as you can, as much as you want. Okay. All right. Last thing here, we do need to talk about something. I think that you guys aren't that familiar with this. It says determine if the speed of the object is decreasing at time 4.5. Speed decreasing, I'm going to put another phrase in here that you see more often. In other words, is the object slowing down? You have to be really careful with this. You have a velocity function, not a speed function. Speed is the absolute value of velocity. The way you tell if an object is slowing down or speeding up is not just to look at the sign of velocity. Okay, you do have to look at the sign of velocity. So I gotta say, hey, wait. Oh, at time 0.5, my velocity is negative. But just because my velocity is negative, it doesn't mean that I'm slowing down. In fact, because my acceleration at that time is also negative, I'm actually speeding up. Okay, my speed is increasing. I know what you're thinking. You're like, wait, how is my velocity negative, but my speed is increasing? I'll explain. Sorry, I made a sign mistake here. My speed actually is decreasing. I am slowing down. Why? Because my velocity is negative. acceleration is positive. Velocity negative, acceleration positive, I'm slowing down. What I wanted to bring up and I thought was happening in this problem is something that we need to talk about, which is, you should jot this down with me real quick, just because I feel like we haven't talked about it a lot. If you're speeding up, there's two possibilities. Your velocity is positive and your acceleration is positive. That's the normal one. But you can also be speeding up if your velocity is negative, as long as your acceleration is negative. If this isn't ringing a bell to you, think about if you're going backwards, driving backwards at negative 10 miles an hour, and your velocity goes down. You're going negative 10, okay, so then you're going negative 12, then you're going negative 14, you're driving backwards negative 15, negative 16, negative... You're actually speeding up even though your velocity is decreasing because it's getting larger negative. Okay, I hope that's ringing a bell to you. That's MAH, and I think we've talked about it a little bit. Both of these situations are speeding up. So then what happens to indicate that you're slowing down? Well, your velocity can be positive and your acceleration can be negative, or your velocity can be negative and your acceleration can be positive. The quick thing to remember with this is just, if your acceleration and your velocity have different positive, negative signs, you're slowing down. If they have the same, you're speeding up. This is the weird one. In this case, though, they were different. My velocity was negative, my acceleration was positive, so I was slowing down. My speed was decreasing. Okay, moving forward. I just tossed this one in here because it's an example of an easy question. Don't let the vocab or kind of the general gist of it make it seem harder than it is. They're giving you a differential equation. We're not solving a differential equation. We're talking about a solution that satisfies this initial condition. This is a point on that solution. They're asking you to write an equation of a tangent line. Now, y minus y1 equals m times x minus x1. They give me the point. That's nice of them. What else do I need? I need the derivative. How do I find the derivative of f? Well, wait. F has a solution to this differential equation, then this is the derivative of f. I'll say that again. If f is a solution to this differential equation, then by definition, the derivative of f must be this. So how do I find the derivative at this point? I just plug it in. I do inverse sine of negative 1 squared minus 2 times 1. I do inverse sine of negative 1. Please make sure you can evaluate inverse trig functions. Remember, inverse sine asks a question. What function, excuse me, what angle has a sine of negative 1? Negative pi halves has a sine of negative 1. Yeah. Here's my tangent. This illustrates a very important thing not to do. Do not try and solve every differential equation you see. A lot of times you don't need to solve them. They're asking you to do things with them. Okay. Moving forward. Okay, I hope this is kind of an easy question. A little MAH throwback. They show us the graph of the second derivative here, and they ask us on what intervals is f prime decreasing. F prime decreasing, so the derivative of f prime must be negative. In other words, the second derivative of f must be negative. Now, well, this is the graph of the second derivative. When is this negative? Oh, like below the x-axis, between 4 and 6. Take a question like that slow, but I hope that's not too bad. All right, moving on. And into this one, so we'll just do it together. We got our function f. It's asking us which of the following has the largest value. And again, I hope this is good MAH stuff we can do well with. F prime of a. F prime of a. Well, don't tell me any numbers, but I know f prime of a is a little bit negative. F of c. F of c just equals 0. F double prime of b. F double prime. Oh, concavity. Ooh, at b it's concave down, so the second derivative has to be less than 0. F double prime of d. Well, this chunk of the graph looks a teeny bit concave up, and that one would be greater than 0, so that one's great. Cool. Last thing here, a little bit of a weird question here, but back to some MAH stuff. They give us a piecewise function to describe our derivative, and they give us this graph which we can use. Okay. They tell us that f of 0 is -2. They're saying first, for what x values does f have a point of inflection? Point of inflection. Okay, a point of inflection happens when the second derivative changes sign. Well, this is a graph of the first derivative. So when does the derivative of this graph change sign? When does this graph change from increasing to decreasing, or vice versa? What happens twice? At time t equals 1 and time t equals 2. We should write a nice justification. I will show you. This is what you need to write. You guys know me. I'm not like I don't do too much. if we could do something less than this, I would. You have to do this. Okay, this is the derivative speak. This is what the points are awarded for on the AP test. So please note that I arrived at these values by looking at the graph, but I also could have used these equations since they did provide them to me. Since f double prime is greater than 0 on -2.5 to 1, and f double prime of x is less than 0 on 1 to 2, therefore x equals 1 is a point of inflection. You have to say it like this. Don't say because f double prime switches sign. That's not enough. Don't say f double prime is positive to the left and to the right. That's not good. Use interval notation and use this. Don't say f double prime is positive. There's a way to say f double prime is, don't say the second derivative is positive. Use this notation. And then a similar thing here. Notice I didn't say it. I didn't say the derivative. I didn't say the second derivative. I didn't say is positive. I didn't say to the left. I didn't say going up. You know what I mean? I used math notation. Okay, so second question here, for what values of x is f decreasing? Okay, so my function's decreasing when the derivative is less than 0. When is the derivative less than 0? Well, this function is less than 0. This derivative graph's less than 0. It looks like on that chunk. I don't know what this point is. I'm going to solve for that on my calculator. That's why they gave me this piecewise function, I'm sure. So I'm trying to figure out where this equals 0. Oops, sorry. I'm going to solve that on my calculator now. I got 0.195. So my answer would be f prime of x is less than 0 on -2.5, 0.195. So f is decreasing on that interval. Okay. Last question here, it says, for what value of x does f attain an absolute minimum? The normal way to find absolute extrema is to check the critical points and the end points and trying to figure out the values of f. I'm not going to do that here because we can do it without doing that. What we can notice is that our derivative of f is negative, 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 positive, 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 0, positive. What that means is this is a relative min, but since the function f is decreasing everywhere before it and increasing everywhere after it on this interval, that relative min is actually the absolute min. Okay. Let's write a justification for that. I'm going to write a little justification like this. I know it's a relative min since basically to the left, and I'm not going to say to the left, I'm going to use my fancy notation, to the left of that of 0.95, the first derivative is less than 0, and to the right, it's greater than or equal to 0. So that makes it a relative min. How do I know it's the absolute min? Well, I know it's the absolute min because if I also compare it to the endpoints, f of 0.95 has to be less than whatever the y value is at negative 2.5 because my function's decreasing between those. So if it's decreasing from here to here, then this has to be less from here to here. And similarly, if it's increasing from here to here, then f of 2.5 has to be greater than f of 0.195. Therefore, x equals 0.195 is the absolute min, or is where the absolute min is. Okay, thanks for sticking in here with me, guys. I know that was a lot of stuff. Again, hopefully that's reminding you about some stuff, or reminding you about some stuff that you need to go and review. Cool. Thanks for watching, guys.